Right, so we're going to continue on the primitive function and look at some applications of it. So when we are given further information about the original function or the curve, we can determine the value of that constant. So remember, we had to add that constant plus c for our integration, because when we differentiate and then integrate, that value could be any constant number, and until we have further information on that, we can't do any more with it. However, now we're going to look at some application where we can determine that value. Alright, so examples I, so dy over dx, so your derivative function. So when you differentiated the original function, you get 2x take away 4. Okay, so we need to find y when, if y equals 5 and x equals 3. So we're told a specific point about the original function, and we can use that to determine the value of that constant. Alright, so we need to integrate that. Alright, so when we integrate dy dx, we have y equals, what's the integral of 2x? Okay, so 2x squared over 2, remember, so we have whatever's there, add 1 to the power, divide by our new power, right, which will become 2x squared over 2, which is x squared. So what would I have to differentiate to get an answer of negative 4?
4x.
So negative 4x. In other words, I differentiate negative 4x, I'll get negative 4. In other words, it is 4x to the power of 0. Alright, for the constant number, you add 1, becomes x to the power of 1, which is just x, divide by 1, and then we have our constant of integration. Right, so we are told information about the original function. So when y equals 5, x equals 3. Alright, so we substitute y equals 5 and x equals 3 to determine the value of c. So 5 is equal to 3 squared, take away 4, what's 3, plus c. So 9 take away 12, negative 3, plus c. So c is going to be 8. Okay, so the original function is y equals x squared, take away 4x, and then we substitute that value for c into what we just integrated. J, f dash of x. Okay, so when you see a derivative, this is the derivative function, so what's already been differentiated, is equal to 6x squared, take away 2x. Okay, so what we need to do is we need to find f of x if f of negative 1 is equal to 4. Right, so we start with the integration. So we need to integrate 6x squared, take away 2x. Okay, so f of x, so when we integrate both sides of there, it's like an equation, we form the integration on both sides. Alright, so we need to integrate 6x squared. So it becomes a 6x, we add 1 to the power, and we divide by our new power. Okay, that's the formal approach to that. Take away 2x, this is the power of 1, so we need to add 1 to the power, and then divide by my new power. And our constant of integration. Alright, so we've got 2x cubed, take away x squared plus c. Right, and at this point it's probably a good idea to do a quick check. When you differentiate this, you should get that, shouldn't we? So differentiate that, we get 6x squared. Differentiate that, we get negative 2x. and we differentiate a constant number, we get 0. Okay, so that's a useful thing to check while we're learning it. Right, so we know that f of -1 is 4. Okay, so what that means is 4, so f of x is 4, is equal to 2 lots of -1 cubed, take away, what's your negative sign? So that's where we need to introduce brackets, plus our constant integration. So 4 is going to be -2, take away 1, plus c. And then solving that, we're going to get c is 7. Right, so once you work out that value for your constant, you just simply plug it into there. So f of x is equal to 2x cubed, take away x squared, plus 7. Questions? Okay. The gradient function of a curve is 3x squared take away x plus 1. Okay, so in other words, y dash is 3x squared take away x plus 1. We can say dy dx, we can say f dash of x. Alright, so the gradient function is your derivative. And the curve passes through the point 2, 13. We need to find the equation of the curve. Alright, so we integrate both sides. Now when we're integrating with respect to x, of course. In most cases you will. Not always though. Alright, so y is equal to 3x cubed over 3. So we add 1 to the power, divide by new power. Take away x, add 1 to the power, divide by my new power, plus the integral of a constant number is that number times x, plus your constant integration. Okay, so we know a point where the curve goes through. So if I substitute x equals 2, y equals 13, obtain a value for c, and then I'll be able to write down the equation of the curve. So 13 is equal to 2 cubed, take away 2 squared on 2 plus 2 plus c. Okay, so this will cancel with that. 2 cubed, so 13 is equal to 8 plus c. So, solving your equation, you're going to have c equals 5. To determine the value of the constant, so y is going to be x cubed, take away x squared on 2 plus x plus 5. Alright. Let's take it one step further, unless anyone's got any queries. Right. Find the equation of the curve y equals f of x, given that d squared y over dx squared is equal to 6 plus 2x. So we differentiated twice to get that result. Alright, so that means to go backwards we need to integrate twice to get the original curve. Okay, so what do we know? We know that x is 2, so this is part of the question. Your dy over dx is 20. and when x is 0, y is 2. Right, so they'll tell you these things in the question. Right, so we need to integrate both sides. So we're integrating this once.
Brandon, because some kid put Monty's jersey in.
Are you kidding me?
No. I'm just in the office. They sent me over to tell you that
Dealing with little shits. Oh my god, what an asshole. Alright, that makes me really mad.
What
They
they
put Monty's jersey in the urinal.
They put it in there. Why did you take it off?
What's going on?
Brendan was wearing his girlfriend's jersey from Tamworth High,
Yeah.
and some little kids took it and put it in the urinal.
Alright, so dy dx, so we integrate once. Alright, so this is the result of differentiating twice. Okay, so we can't integrate twice straight away, we need to do it step by step. Alright, so what's the primitive function of 6? 6x. Okay, so this is x to the power of 0, add 1 to the power, and what's the primitive function of 2x? Squared plus the constant integration. Right, so we need to go back to the original condition. Dy dx is 20 and x equals 2. So 20 is 6 lots of 2 plus 2 squared plus our constant integration. So 20 is going to be 12 plus 4. So C is going to be 4. Alright, so your dy dx is going to be 6x plus x squared plus the value of the constant that we just determined. Okay, so that's just the first derivative function, so in other words the equation for the gradient of the tangent. Alright, so we need to still get the original curve, so we still need to integrate. So y is going to be 6x squared on 2 plus x cubed on 3 plus 4x plus our second constant of integration. Now, you will get away if you just left it as C, however, we don't want to fall under the impression that these are the same values, okay? So that's why I've labelled C1. Although you probably will get away with it, but it's just a habit of what that means. I don't want you to sort of get confused about that in there. Right, so we know that x is 0, y is 2. Right, so we substitute x and y in there, solve for C1, and then we'll have our original equation. So 2 is going to be x is 0, so we need 0, 0, 0, and C1. Okay. So we've already determined what it is. That's great when we have x equals 0 because that will allow us to do these things pretty quick. So y is going to be, so we simplify now. So it's going to be 3x squared plus, plus x cubed on 3 plus 4x plus 2. Okay. Usually they're in decreasing powers, but the question didn't give it to you like that, so no need to put your answer like that. Alright, so this one, you will need to go back a chapter in your textbook. Okay, so this is exercise 2.12. Alright, so we're covering chapter 3, you are going to go back a chapter to get that one done.